In this short video, we'll discuss some basic rules of the derivative and how to use those rules. First, constant rules. The constant rule says that if you find the derivative of a constant multiplied by a function, you can first find the derivative of the function f of x and then multiply the constant to the derivative of f of x. For an example, the derivative of -3 times e to x, we can use the constant rules. And we see that the constant is -3. We can move it out and multiply -3 by the derivative of e to the x. And the derivative of e to the x is just e to the x. So then we get to the answer of -3 times e to the x as a derivative. Power rule. The power rule says that the derivative of x to the n is going to be equals to n multiplied by x to the n minus 1. For an example, if you want to find the derivative of x to the fourth, then you know that n equals to 4 as a power. So you take 4 times x to the 4 minus 1. You know that 4 minus 1 is n minus 1. So we get the answer is 4 times x cubed. The sum and the difference rule. The sum and difference rule says that if you find the derivative of a sum or a difference of the two functions, we just find the derivative of each of the functions and we combine them together using the corresponding plus or minus sign. For an example, if you want to find the derivative of x squared plus cosine of x, you can find the derivative of x squared plus the derivative of cosine of x, which will give you 2x minus sine of x. Here are a couple more of the examples of how to use those rules. Let's say we want to find the derivative of these functions. But the first thing you want to think about is, can you simplify the functions? And the answer is yes in this case. You can separate the numerators using the denominator into two terms. X squared, x cubed divided by x squared, minus square root of x divided by x squared. So for x cubed divided by x squared, using the property, exponential property, it's going to be equal to x. Similarly, using the exponential properties, it's going to be x to the 1/2 minus 2 equals to x to the -3/2. So now, if we want to find the derivative of these functions, we can use a power rule for each of the term. So power rule for x is going to be 1, x raised to 1 minus 1. And using the power rule for x to the -3/2 is going to be -3/2, x to the -3/2 minus 1. Simplify all the terms together, you get 1 plus 3/2 times x to the -5/2. That's the answer. And if you want to get rid of the negative exponents, you can move the x to the -5/2 to the denominator. The next example is f of x equals to cotangent of x divided by cosecant of x. Again, you want to ask yourself, can you simplify this function? And the answer is yes in this case. Again, cotangent of x, you can rewrite it as cosines divided by sine. Cosecant of x, it can be rewritten as 1 over sine. So cosine over sine is the simplest form you can get, but divided by 1 over sine x is similar to multiply by x. And in this case, you can simplify sine x's to get to cosine of x. So you simplify the function f of x down to just cosine of x. So just need to find the derivative of cosine, which is negative sine of x. So by the conclusions, if f of x is cotangent of x divided by cosecant of x, then f prime of x the derivative of the f of x equals to negative sine of x.